So question 5 part 3, we've got this integral to do here using the substitution x equals 4 tan u. What's different here is rather than a u equals substitution, I've got an x equals. So it's like I might think of this like, imagine this was y equals 4 tan x and you differentiate, you find dy dx. You differentiate with respect to this variable here. In that case it would have been an x, but in this case I've got x equals 4 tan u, so I'm going to differentiate with respect to u and get dx du. So I'm differentiating with respect to u and I get 4 sec squared u on the right hand side. Again, separating my x's and my u's, so 4 sec squared u du is what dx equals. Now, x squared, well, we can just work out x squared over here, just so I'm prepped. So x squared equals 16 tan squared u. And when x equals 4, then tan u would equal 4 over 4, so tan u would equal 1, so u would equal pi over 4. Just check that for yourself, so x is 4, then 4 divided by 4 is 1, and the inverse tan of 1 is pi by 4. And similarly, when x equals 0, then 0 divided by 4 is 0, so when x equals 0, tan u equals 0, or u equals 0. So we've changed our limits to pi by 4 and 0. So I think we're ready to go now, because we can substitute everything. We've got the 16x squared, and we know x squared is 16 tan squared u, and the dx is 4 sec squared du. So let's go for it in one go. Substitute everything in, so this becomes integral between pi over 4 and 0 of 1 over 16. Now x squared is plus 16 tan squared u, and dx is 4 sec squared u du times 4 sec squared u du. Now good things should happen here, and if we are careful and remember some trig identities, they will. So we've got 16 as a factor on the bottom and 4 on the top, so we've got 1 over 4, so it becomes 1 over 4, the integral between pi over 4 and 0, that's it, of sec squared u du over 1 plus tan squared u. And so at this point I'm thinking trig identities, and I always remember, make sure you can see the paper, yes, sine squared plus cos squared equals 1 is my sort of starting point, and if I divide by cos, I get tan squared plus 1 equals sec squared. So 1 plus tan squared, or tan squared plus 1 is sec squared. So this 1 plus tan squared u is just sec squared u, and sec squared u over sec squared u is just 1. So it becomes a really trivial integral of pi by 4 and 0 of 1 du. So it's a quarter u between pi over 4 and 0 equals pi over 16. Oops. And obviously I can check, put the original interval back into my calculator. I got it correct.